Hello, Cyril.
Hello, Mahad. How are you?
Yeah, I'm fine. How about you?
I'm very good, thank you. Yes. This is really awesome for us to be here. We also welcome our audience online, connected from all the different parts of the world. So, good afternoon, good morning, good evening, depending on where you are. It's great to have you join us for this session. Um, Trusted Advisors Group, it's very is becoming increasingly interested in this area of artificial intelligence, and hence why we have these sessions running kind of on a monthly basis. So, Moad, I would leave you to do a quick introduction for our audience.
Yes, of
Yeah.
course. So this is the
Okay.
second edition of AI Cafe Break, which is an event organized by Trusted Lab of Trusted Advisors Group, and where we will discuss topics and issues related to AI and data science. And our topic today is AI, machine learning, deep learning. What are the differences? And it's a very important question because today we tend to use these three terms to mean the same thing, while there are some major differences between the three technologies. And it's important to distinguish them and to be able to understand what kind of relationship they have. So this
Yeah.
is what we will try to do in this live session, the second edition of AI Cafe Break, organized, as you said, by Trusted Lab, by Trusted Advisors Group.
Yeah, I mean, I would like to also add, Moab, that it's really great. We thank you for helping with supporting us to have these sessions set up. For those of you that don't know Moad is our junior consultant in the area of artificial intelligence, and is playing a very key role in our Trusted Advisors Lab section of the business. And of course is here to share some insights with us. So I'm going to be asking Muad some questions, and Muad is going to be sharing his thoughts on those, and then of course we're going to invite you, our audience, to come up with your questions towards the end, and we will try and address those. Yeah, so that's really great. So Moad, you're chronologically speaking, what would you say would be the order of these different technologies that have come on into the scene? These three key technologies that you're going to talk us through. Maybe some history and some background. Yeah.
Yes, some history. Yeah, Richard,
Mm.
very important question because we need really to know the origins of these three technologies to be able today to understand them and use them in the right context. And if we want to situate these three technologies in time, we have to say that back to 1950s, we were already talking about AI
Right.
the first games of checkers and chess developed by scientists and researchers, and which ended up acquiring a sufficient level to challenge a good amateur. And
Mm.
this is really where it all started. And scientists begin to dream and begin to think that maybe one day we will have the possibility to create machines with real intelligence. And this is it for AI in this era. 3 decades later, 1980, this is time for this time is for machine learning, which means it's appearance for the first time. And why exactly in this era? Because we started to have some great progresses in terms of computing capacities of computers, and also development of computer science. And at this time, the approach changed. And really,
Mm.
this element is a key element in the story because scientists and researchers moved from, I would say, from a knowledge-based approach to a data-based approach. So here we begin to understand that data is an important element in the process. And if we are really able to analyze a huge amount of data, to understand the data, to extract meaningful and insights from this data, and to learn from this data, to draw conclusions, we are really more closer to the human intelligence. So at this time, at this era, the scientists and the researchers changed the approach and begin to develop some great algorithms still used today for performing some tasks like classification, like prediction, or like clustering. And so this is it for machine learning. Again, this time, 3 decades later, 2010, it's time for deep learning. Deep learning, which is, if I were to say that, some sort of algorithms that are based on artificial neural network. And to make this very easy to our audience, it's simply some sort of algorithms that are performing the same tasks like machine learning, prediction, classification, or clustering, but this time with more accuracy, with more precision, and based on a network structure with nodes, with links, and with multiple layers. I would say 1,000 layers that data crosses from the input to the output to draw a conclusion. So this is early deep learning, and this is a revolution. Why? Because we begin to imitate to a large extent the way the human brain works, and we are more closer to the human intelligence that scientists and researchers of 1950 wanted to reach with their first games of checkers and with first computer programs. So this is the history or the chronology of these three technologies, and thanks to this continuity on the history that we are able today to do some such great things with AI, machine learning, and deep learning, Cyril.
Right. Yeah, that's really it's a, as you describe Moad, it's very interesting how the pace of development has really sort of has been very, very fast in terms of development, and we see as well that organizations that use data very well tend to be very, very successful, right? We all know of organizations like Amazon, Apple, all these tech companies are using data very, very heavily. So data is like the new currency almost, right? It's no longer oil or gold or bauxite or whatever. Data is like the real new currency. So yeah, thanks for sharing the history behind that. So you explained the three key areas there, being artificial intelligence, machine learning, and deep learning. And what would you say is the relationship between these three different technologies, and how can we define them today? Do you think?
Yes, it's a key element in the story, Cyril, because to distinguish these three technologies, we really want to know what kind of relationship they have. And to explain this, I will base myself on a schema developed by Microsoft,
Yeah.
which modelize perfectly the relationship between these three technologies. And as you can see, AI is seen as the universal umbrella. It regroups a lot of domains and technologies and any techniques that imitate or mimic the human intelligence. So this is AI, and there are several domains on AI that we will explain later. And among these fields or domains, we have machine learning. Machine learning, which is a subset of AI, and where the algorithms, where we give the machine the capability or the ability to learn from data and to perform some specific tasks based on that learning, tasks like classification, again, prediction, or clustering. And the third element, which is again deep learning, it's a subset of machine learning, but it's used for more complex tasks or advanced tasks. And the algorithms used here are based on, as I said, artificial neural network, and it's used to perform some tasks like computer vision, like facial recognition or voice recognition. So this is more, if you want to say, more difficult task that we could not do it with. It's easy with machine learning. So this is really the relationship machine learning, AI, and deep learning have, and it's important to as I said, to see AI as the universal umbrella that contains or regroups a lot of domains and fields in this of AI and machine learning and deep learning.
Great. Okay. So yeah, it's good to share the kind of the three key different areas there. I'm sure those are that you've just described a very, very high level, but there's a lot of content in each of those three areas. So I think now we can move on to the meaty part, right? Which is how what is the most practical use cases for these three technologies, you think? Can you give us some examples of these three key areas here and how they are being used in industry for positive business outcomes? Yeah.
Yes, Cyril, we talked about chronology, we talked about theoretical part, but now it's time for, as we said, the more the important part, which is use cases and real use cases for AI, machine learning, and deep learning, and when we should use AI, machine learning, and deep learning, and where. Okay, so to explain this, I will just base myself again on a schema to see the panorama of AI domains and to see really the differences between every technology. And as you can see, AI is the universal umbrella, and it groups a lot of domains like expert systems, robotics, planet optimization. We have also speech, text to speech to text services, and it's very used today. Some leaders on this field like Amazon Polly or IBM Watson. We have also computer vision, like image recognition or artificial vision, and this kind of technology. It's used on social media like Facebook or Twitter to do some facial recognition on images on social media. And we have also a very important domain, which is natural language processing. It's really very important today because we use it every day in translation, for example, or in classification of text or extraction of information with also virtual assistant. Siri of Apple or Microsoft Cortana or Amazon Alexa, they are all vocal assistant and virtual assistant where we have to understand the human language and to be able to extract meaning from this language to interact with the human. So this is an important field for AI. And among all this field, we have machine learning and deep learning. So this is the panorama and the overview and of AI. And to explain more about this time about machine learning in practical cases, the important thing to know is that machine learning, as I said, is giving the ability to the machine to learn from data and perform some tasks. Mainly with machine learning, we do three types of tasks. We do prediction, we do classification, and we do clustering.
Right.
And we have, if you want to say, we have two mainly types of machine learning. We have the supervised machine learning and we have the unsupervised machine learning. So the difference is in the supervised machine learning, the human intervention is still required because we have to pre-process the data and to prepare it for the model and to label the data. What does mean that we have to give the model an information saying that this is what we want to predict or this is what we want to classify. And in a practical use case, I would say that for churn prediction, for example, churn prediction for banks, for insurance, or for other companies, we use this type of learning with supervised learning for being able to predict classes, and we base that on, for example, customer data, demographic data, or historic transaction history data, and we have also an information which is called the label here, which says to us this client or this customer is still active or this customer have churned. So this is really in terms of the model. This is a 0, 1, 0 for the customer still active and 1 for the customer that churned. And this is an example of the supervised machine learning. So the algorithm here will analyze the data and understand what is the features or characteristics that lead a customer to churn, and will be able in the future to predict on some new data and never seen data, if you want to say that, with a new customer profile. So this is very use case, and it's the supervised machine learning. It's very used also in prediction, like predicting the cost of an accident for insurance companies, for
Yes, yes.
or in on other areas like classification of emails to spam or not spam. So
Mm.
this is mainly what we can do with supervised machine learning, classification and prediction task. What
Yeah.
about the unsupervised machine learning? The unsupervised machine learning is really when we don't know our output. We don't know what is hidden in our data. We don't know really how many segments, etc., we have in our data. And the algorithm here will do the task and will discover and find the hidden pattern in the data to draw a conclusion. For example, for this type of learning, again, this time for banks or other companies, customer segmentation. In customer
Mm.
segmentation, the bank don't know how many segments there are in their customer in their customers group, and what are their characteristics. So here it comes the role of unsupervised machine learning to draw conclusions with how many segments we have, what are the characteristics, what are the similarity, and what are the customer behavior
Mm.
of every customer in every segment. So this is
Yeah.
a very important use case for unsupervised machine learning, and we have other some use cases, of course, in other domains like for digital platforms. We know them for
Mm.
streaming today, Netflix for streaming films, or Spotify, Deezer for streaming music. They use unsupervised machine learning for recommendation systems. So this is
Mm.
really what machine learning it's used for.
Mm.
Three tasks.
Yeah, yeah, I can see here, Mahad, sorry, that the supervised learning is probably for the finance sector an opportunity to reduce risk, right? Using data to be able to see a certain pattern and making sure that the risk exposure is kept to a minimum. Whereas the unsupervised learning is also very useful for understanding our customer, right?
Yes,
Really gets to
exactly.
know
For
our customer.
understanding the behavior of our customers, and as you
Yeah.
said, reducing risk with supervised machine learning, because here the
Mm.
bank or the company in general understand what are the needs of their customer and anticipate every type of
Yeah.
problem. Like churn, for example, if we are able to anticipate that types of problem, we are really leverage the impact of machine learning and supervised
Mm.
learning exactly.
Mm.
And
Awesome.
and
Good,
yeah,
good, good.
we
Yeah,
have
that's very, very,
yeah.
yeah, yeah, very, very useful sharing that with us, Moad. So let's talk about trusted advisors. Of course, we are hosting this, so it would be good for us to kind of mention what we are doing in this space. For of course, our existing customers and our prospective customers. So hopefully, we'll give some indication of how we can provide support in this area of artificial intelligence. So, what would you say are examples of projects that we have covered, for our clients in this area of artificial intelligence? Uh,
Yes, Rishad. We in Trusted Lab, or exactly by Trusted Advisor Group, we worked
yeah.
on several projects with our clients in terms of setting up AI and machine learning projects. And
Mm.
as an example, I will share my screen and
That'd be
uh,
great. Yeah.
and give an example of customer segmentation in banking, a project we worked on Trusted Advisors, and where we set up an unsupervised machine learning model for clustering, as I explained now, for detecting the different segment on the data and be able to extract, I would say, characteristics and similarity between those clusters or those segments. And clearly, our client or the bank will be able after this to improve their targeted marketing and to target a specific segment with a specific strategy, and to know exactly what are the needs of their customer. And also they can guarantee that the customer retention in another part Sarah. This is an example of a first project which is based on unsupervised machine learning for a
Hmm.
classical task. And Also, I will share another example this time for supervised machine learning for binary
Right.
classification task. And this is about customer churn prediction. This is a project where we will set up a supervised machine learning model to predict whether a customer will churn or not, and with the probability of that. So the
Yeah.
bank will clearly improve customer retention and
Mhm.
reduce costs, because as you know, to retain a customer is 5 times cheaper than acquiring a new one.
Absolutely.
So
Yes.
this is really important for the bank to know, understand the needs of their customers and be able to
Yeah.
anticipate this type of problems like churn, which is really bad for any type of companies. And also we
Yeah.
have maximize profit margins. As I said, selling to existing customers is more likely and cheaper than selling to new ones. So this is
Mm.
the benefits and advantages of AI project leads by Trusted Lab of Trusted Advisor Group, and with our clients, of course, Sarah.
Great, thank you, Muad, for sharing that. So we you know with Muad's help, we have covered the very high level aspects of artificial intelligence. Over the coming months, we'll be covering each month we're targeting to cover a section on this topic, and hopefully this session has given you, our audience, a very kind of this high level view. And what we would like to do is that we would like to invite you, our audience, to send us your questions, any questions that you have. We kind of thought it'd be good to leave a few minutes for your questions. So if you have any questions now, please feel free to post them, and Moad would support
Yeah,
with answering those. Yeah.
yeah, we have some
Um,
question here, I think. So I will
we
just
do.
yes.
Okay, great. Let's
Okay, so
go
the first
go through
question,
this.
can you clarify what kind of models do you use for churn prediction? Very important
Right.
question. In churn prediction, as I
Mm,
explained, we use supervised machine learning, and we have some several algorithms to do that, from
mm,
random forest classifier to decision trees to XGG boost classifier. We have really some, I would say, hundred algorithms to do the task. But
mm,
we are what we have to do here is to benchmark those algorithms and to see the accuracy and precision of every algorithm on the task of classification and prediction, to be able to choose one and to use this one for predicting on new data, never seen data by the model. So this is a
mm.
great question, and we have other
Good,
questions
good.
here.
Yeah, we have some more questions there. That's good.
Another question, what are the accuracy
Mm,
that you reached in your AI projects? How large is the data you are managing in your projects? Okay, yeah,
mm,
the accuracy, as I said, when we do our benchmarking, yeah, the goal here or the objective is to reach a high accuracy
mm,
of prediction. I would say about 90%, above
right.
90%. Okay,
Mm-hmm,
so this is accuracy in general we have reached with AI project we set up for our clients. And the volume of data is really huge. We have
mm-hmm,
millions of lines, millions of customer data to handle and to deal with it and to pre-process for the model. So this is for
So I
the
presume it requires obviously using the right tools in order to
yes.
manage that large volume of data, right?
Yes,
Yeah.
it's really
Mm,
in the field of big data. We are in the big data, so we will use some
yeah.
framework and some tools for dealing with this huge amount of data, if you want to say that.
Mm-hmm, yeah.
So,
Yeah.
yeah, another
Excellent.
question
Good.
here.
Right.
We have some clever question.
Mm,
So, what are the challenges you are facing when you adopt models for specific proof of concept? What are the requirements? Yes, very important
right.
question from Marin.
Mm,
Yeah, there are several challenges, Cyril, on data-centric project in general.
yeah.
Sometimes we have some missing data. We have some data with irrelevant information or not relevant for the machine learning model. So
Mm-hmm,
every time we will do some pre-processing. I would say that 80% from the work is in processing the data and prepare it for the machine learning model to make it in a format that the model can learn from this data. So this is some challenges, and there are, I would say, there are a lot of challenges in terms of computing capacities and moving to cloud to do some tasks and some computation tasks clearly with huge amount of data. We couldn't do that on local machines. We need to use some sort of clouds like AWS or like Azure of Microsoft. So this is mainly the challenges, I would say, for data and AI
So
problems.
it's important that the data is clean, if you like, isn't it, in order to make some sense of it, right?
This is the optimistic scenario.
Yeah.
But it's never clean.
It's never clean. Yes, of course. Yeah. Awesome. Good. Okay. I don't know. Do we have any more questions, or we're coming up to time anyway? So
I think we're around 30 minutes.
yeah, yeah, yeah. So I don't want us to. I would like us to commit to the time that we gave to our audience, right? So from a time management perspective. But yeah. So in conclusion, really thank you, Moad, for sharing your insights and your learnings with us. And our audience, hopefully you have gained something new, right? Every day we learn something new, and hopefully the insights that Moad has shared with us, you've actually grasped something new there. And as we say, we will definitely be continuing with this on a monthly basis. So we look forward to seeing you again in a month's time. So you can see on the screen there, we have, we would really love to get your feedback on how you think this session went. This is also helping us to, opportunities to improve if we have to in any specific areas with our sessions. So please feel free to visit the link there, menti.com, and use this code that is shown there to, provide us with your feedback on how you think this session went. So yes, once again, I would like to say thank you to Maad, and thank you to our audience for joining us for this session, and we look forward to seeing you again soon. Yeah.
Yes, thank you, Cyril.
Awesome. Thank you. Thank you, everyone.